right, let's work with some tangent problems here. We're asked to find the tangent of angle A plus angle B given the following values. So we're going to use our identity for tangent when we're doing a sum right here. Tangent A plus B equals tangent A plus tangent B over 1 minus tangent A times tangent B. Now notice there's one thing that comes into play here. In order to use that identity, we need to know what tangent of A and tangent of B are, and we're given sine and cosine. So our first job is to find tangent A and tangent B so that we can actually use our identity. Now remember, tangent is equal to sine over cosine. That was one of our earlier identities. So we take the sine of A, which is 35 over 37, over the cosine of A, which is 12 over 37, and we simplify. Well, we have a fraction divided by a fraction, and our rule for dividing fractions is that you invert the second fraction, or the denominator there, and multiply. Well, notice our 37's cancel, and we're left with 35 over 12. If we can reduce that, we would want to reduce, but that does not reduce. So we know that now. We know tangent A is 35 twelfths. We also again need to find tangent B. So now let's find tangent B in a similar way. We're going to do the sine of angle B over the cosine of angle B. The sine of angle B is 5/13. The cosine of B is 12/13. Again, to divide fractions, we invert and then multiply. So we have 5/13 times 13 over 12. The 13's cancel, and we're left with a tangent B is 5/12. Now we can use our identity. We had to do that preliminary work first, but now we can use it because we actually have the values you need. Okay, so again, now we're finding tangent A plus B. Okay, the identity says that's equal to, hold on just a second, there we go. The tangent of A, which was 35 over 12, plus the tangent of B, which we found to be 5 over 12, all divided by 1 minus tangent A times tangent B. So 35 twelfths times 5 twelfths. Okay, all right, let's keep going. So let's simplify the top here. They already have a common denominator, so we can go ahead and add. 35 plus 5 gives me 40 over 12. And in the denominator, I get 1 minus, if I multiply here, 35 times 5 gives me 175, and 12 times 12 is 144. Now here I'm going to assume that you're doing this by hand. I know many of you have a calculator with a fraction button, and that's okay. If you don't, we would have to get a common denominator here to combine these. 1 we would write as 144 over 144, and then we could do the subtraction. So now we have 40 over 12 divided by 144 minus 175 is negative 31 over 144. Okay, again, we need to simplify that, so we invert the denominator and we multiply. Flip that bottom fraction, so we have negative 144 over 31 instead. Okay, let's do any reducing that we can. Let's see, 12 goes into 144 12 times, so that does a little bit for us. We go ahead and 40 times 12 then, times negative 12 is negative 480, and in the denominator, 1 times 31 is just 31. So our tangent for A plus B is negative 480 over 31. And that's the exact value. Sure, your calculator will give you a decimal value, but the exact value would be harder to track down. Okay, so here is one more example. If you got it down, great. If you want to try this one out, And then while it's paused, and then push play to see how I did, that's great. Or if you want to go through it with me, perfect too. Right? So again, we're asked to find tangent A plus B, and we're given sines and cosines. So what we are going to do is first find out, according to what we are given, what tangent A would be and what tangent B would be. Again, tangent is sine over cosine. So the sine of A is 8/17 over the cosine of A, which was 15/17. Again, to simplify that, when we're dividing, we invert the second fraction or the denominator and we multiply. The 17s cancel and I'm left with 8/15. So up here I'm going to put, all right, now I know that the tangent of A is 8/15. We also need to find tangent B. So let's do that. We would take the sine of B, which is 12/37, divided by the cosine, because tangent is sine over cosine, which was 35/37, and simplify. So 12/37 times 37/35. And we're left with 12/35. So tangent B is 12/35. Now that we have tangent A and tangent B, we can use our identity for tangent A plus B to find our answer. Okay, so tangent A plus B, it said, is equal to tangent of A, which we found to be 8/15, plus tangent B, which we found to be 12/35, all over 1 minus, important you get the right sign there, tangent A times tangent B. So 8/15 times 12/35. We want to simplify here. One problem, we don't have a common denominator this time, so we will have to create one. Okay, you can look for the least common denominator, or you can just multiply each. The least common denominator for 15 and 35 is 105. Okay, and to get that here, I have to multiply by 7. So I do the same to the top. So again, if you're doing this on a calculator with a fraction button, just use your fraction button and add those. But if you're not, these are the mathematical steps we'd have to use. 35, to get it to be 105, also would have to be multiplied by a 3. And notice what happens in this one. 7 times 8 gives me 56 over 105. And here 12 times 3 gives me 36. And then I have 105. In the denominator here, what happens? Well, if we multiply those, in the numerator, 8 times 12 is 96. And in the denominator, 15 times 35 is 525. Okay, to move on from here, in my denominator here, again, I would need a common denominator, which I would go with 525. So 1 I could write as 525 over 525, and I'll be able to subtract. Okay, so in the numerator here, I have 56 minus 36. I have my common denominator, so I can, or excuse me, 56, oh, that was almost bad, 56 plus 36, which gives me 92 over 105. In the denominator, 525 minus 96 is 429 over 525, which you could have reduced that. Just so you know, if you reduced it, I do. You could have reduced it. At the end, we're going to reduce. When we get here, again, we have to simplify that. So remember, that means we invert the second fraction and we multiply. Okay. Now, at this point, it's usually easier to reduce right here than to reduce at the end, but you're welcome to do it either way. Want to see if there's anything common in the numerator and denominator that we could use to break these down. Okay. And actually, this fraction here, 3, goes into both of these. So 525 divided by 3 leaves me with 175 here, and And this is not more to do with the tangent, but just reducing a fraction. 429 divided by 3, 3 goes into that 143 times. Is there any more reducing, like between the 92 and the 143, or the 105 and the 175? And we'll notice 5 and 175 both end in a 5. Okay, actually 35 goes into both of those. 35 goes into 105 3 times, and 35 goes into 175 5 times. So I'm left with 92 times 5 gives me 460 for my numerator, and in the denominator 3 times 143 is 429. And again, you would check just to make sure you reduced fully, see if that fraction reduces at all, but that does not. So my final answer is that the tangent of a plus b in this situation is 460 over 429. All right, we are going to be using the sum identities again, and this time we are going